Good morning all, welcome to my channel VJ's Physics Print. Today we'll discuss about rotatory motion of spool or the reel. So is a spool or the reel, it consists of two different radii. Is actual shape of the spool, two different radii. Inner radius it is taken as R and the outer radius it is taken as capital R, and totally it is a wire or thread is going to be wound around this. Now pulling the rope from the lower end with the force of F as shown in the figure. So about the point of contact, about instantaneous axis of rotation, the force it is in clockwise direction, so that the spool it is moving in forward direction with acceleration A, and the friction it should be backward direction F. Now here I am calculating what is the acceleration as well as what is the friction force. So here applying the translational equilibrium, that is translational equilibrium, F net force which is equals to ma, and torque acting from point of contact. So here to here it is a radius r, and here to here it is radius r, the remaining distance which is equals to r minus r. So about point P, the torque I am applying here about point P. So there is a force and perpendicular distance. So force and perpendicular distance, that is torque tau is equals to I alpha about point P, and alpha is angular acceleration. Torque formula is a force and perpendicular distance, moment of inertia about point P. From this I am writing the value of alpha. Alpha is nothing but linear acceleration by the radius. From this acceleration, if I am writing here Fr r minus r by Ip, say this is equation 1 and this is equation 2, substituting equation 2 in equation 1. So therefore we are getting the value of friction, that is F minus F, which is equals to ma. A already we got from the equation 2, which is already substituted, and solve for the friction force. So the final equation after solving for friction force, F is equals to, so F of 1 minus mr of r minus r by Ip. So where Ip, which is nothing but moment of inertia about point P, which is can be written as Ic plus mr square. So if you substitute here, we will get the final equation for the friction between the spool as well as the surface. Now the force is applied at the upper end of the wire or the string. Is a force, is a point of contact where the instantaneous axis of rotation about point P. Again the force produced in clockwise direction torque, so that the spool it is moving in forward direction with acceleration A. Now the frictional force it is F. Applying the translational equilibrium, the net force net force, which is equals to ma, equation 1. Now about point P, applying the torque tau is equals to ip alpha, moment of inertia about point P. Torque due to the point P, so this is a distance r and this is r plus r, total distance is r plus r, force into perpendicular distance ip, and this is a by r. So writing the value of a, which is by ip, equation number 2. Now the substituting the value of equation 2 in equation 1, solving for frictional force ma, already we got r plus r by ip, so frictional force by ip, right, that is frictional force, that is f of 1 minus mr r plus r by ip, where ip value, the value of ip, which is equals to ic plus mr square, is the moment of inertia, and the perpendicular distance, that is ic plus mr square or I plus mr square. If you substitute the value of ip here, which is frictional force F is equals to F of 1 minus mr r plus r ip stands I plus mr square. Now taking the LCM, that is I plus mr square, and expanding, so here minus mr square plus mr square is cancelled out. Then the final equation for friction, you will get F of I by m minus rr by I by m plus r square. It is a friction when the force it is acting on upward direction. Here the value of I by m and comparing the value of rr, if the value of I by m, which is equals to rr, then the value of friction is going to be 0. It means no friction it is acting between the spool and the surface. If the value of I by m it is greater than rr, then friction should be act that to be in backward direction. The value of I by m is less than rr, then friction is going to be negative value. Negative, it is nothing but the friction is going to be acts in forward direction. Okay, thank you.